Welcome back to Arcade. I am Super Tommy, and in this video we're going to look at Spaceship Lander controls in Phaser 3. So you've probably seen a couple of videos already with the spaceship landing controls example. We've used it in our MobX for game state video and our weighted table, smart random with weighted tables video. So in this video we're going to show you how to actually create that effect of controlling a spaceship with two thrusters, so a left one and a right one, so that you can move right or move left by turning on and off thrusters, and then being able to kind of hover in the air as a landing spaceship would do if both thrusters were on. And now one thing I'll show you in this video, as well as a game I've worked on that's very similar to this. Alright, we're going to show you this spaceship landing controls example in three parts. First, I'm going to talk about these two thrusters on the ship. Your ship could have more thrusters in theory, but two is a pretty good one, or one. Having more than that does seem kind of weird. So we have two thrusters here to move left or move right. And when we'll talk about how to add these particle systems to each side so that you look like you have exhaust coming out. So that's the exhaust particle section. Then in our code example, we're going to show you how to actually implement this in a Phaser 3 scene. Let's get started by looking at these two thrusters. Okay, so our ship in this example here is going to have these two thrusters at the bottom, the left one and the right one. What we're going to do is going to add two particle emitters to it. So what happens in Phaser is going to create a particle emitter manager, so just one of those. And then from that particle emitter manager, we're going to make two particle emitters from it. And that's how we're going to have these exhausts come out. So what's going to happen is if you're moving right, the left thruster is going to turn on, and we're going to make that particle system, particle emitter, have more gas coming out of it, and the right one have less gas, so that it looks like the left one is moving the ship. And just very briefly, the game I worked on was called Propaganda Lander right here. It was for iPhone. I don't think it's available on the iOS App Store anymore, but this game, you see this, there's a ship there, and you would land the ship on a house there just to collect dudes. There's a story involved in this. I think this particular UI here is the older one. This game was refreshed for iOS way back many years ago now, but it has the same idea. You land on the ground somewhere, collect people, bring them up to a mothership. So that was a fun little trivia for you guys. Okay, now let's talk about these exhaust particles. So how we're going to move is when the ship kind of rotates. So if you have your left exhaust or your left thruster on, we're going to rotate you to the right and then turn on that left thrust so that you move in the direction you're kind of facing, right? We've talked about a lot of that in different videos here on this channel, but you can just move in a direction towards where you're facing, which is what we're going to do when we turn on the left exhaust left thruster. We're going to thrust to the right because we're going to rotate you to the right. And then we'll do the opposite when it comes to the right one turning on. We're going to rotate the ship more towards the right, and then you're going to start moving in that direction. We're also going to be using Matter.js in this video, so we're going to use that physics engine to help us a lot here. And see in our graphic here, we've got the rotation of the ship, and then those particle emitters that I talked about, they aren't going to automatically just position themselves in the right place. We'll have to actually position it manually. So what we see here in that third picture on the bottom right, you see there's like an angle that we gotta rotate our emitters based on the rotation of the ship. So we're going to show you how to do all of this in the code right now. All right, here we are in VS Code. So we're in our game scene. We've kind of simplified this from the other videos that use this as the example. And so we've got our left and right exhaust here. These are going to be particle emitters. Like we talked about, we're going to make a particle emitter manager. Then we're going to make two particle emitters from it. These are our left and right ones. They're not being used right now. We're going to fill that in together. Now let's come down. These are just general loading. So here, we're making our particle emitter manager. So this .add.particles creates a particle emitter manager. And then from that emitter manager, we're going to create two emitters. And that's the left one and the right one. So now how do you get these values here? I would say you get them just by playing around with it. So things like acceleration Y, acceleration X, how many you want, the lifespan of it. So these are in milliseconds, 100, 300 milliseconds. The alpha as it goes through its lifespan, the rotation, the angles, the scale. You kind of play with it until you get it to look and feel right. And then, afterwards you can just duplicate it for your right one once you do the left one. So that would be the easier way. Instead of doing them both at the same time, you do one, it looks good, then you just make it for the second one. So that's for these type of particle systems. It will basically apply to any particle you want to do. Just playing around is the best way I've known to do it. There are tools that will visualize this for you as you make it. But if you don't want or you don't have one of those, this would be the best way I know. If you've got better strategies, do let me know in the comments below because I'd love to know too. Okay, so we have our particle emitters here, and we're going to position these manually in our update loop as our ship moves. But before we do that, let's just come down here to our ship. So we make our ship right here. This is just a matter sprite, and we give it a circle body just for simplicity here. Radius 64. It'll be different depending on your asset, but in our asset's case, that's what it is. And important to note here, in phaser, things have the right hand rotation. So what happens is if your asset should face right, so that's where 0 is. So that's where 0. So let me just show you the graphic here. Let's go to public. Let's go to our yellow ship. So you see here, it's basically rotated on its side. But this is 0. This is what 0 degrees is in the phaser system, the right-hand coordinate system. And so let's come back here to game. And so because this is 0, where it was laying down, to make it face upright, let's say, we just do minus 90 degrees so that it rotates itself 90 to the left. And then it looks like it's standing up in what we understand would be 0 in our minds. But so in phaser, 0 is facing right, but we want our ship to be this way. So we rotate it back minus 90 to get it looking correctly. Now let's come down to our update loop here. We have our cursor keys to check which keys are down. That's pretty standard. And what we want to do when the right key, the right arrow key is pressed, we want to move to the right, which means we turn on the left gas or the left thruster and we emit particles from the left particle emitter. So to do that, let's go here. We want to do the ship's angle should basically rotate positive. Since rotating negative, like up here, minus 90, right here, rotates you to the left. From where 0 is, left 90 degrees is minus 90. So to move to the right would be adding degrees. So let's do this dot ship dot angle. And we're going to want it to be, you can just do this, right? That'll move it to the right. But we also want to lock it from over rotating in this particular type of game. So instead of doing that, we're going to do math.min. So we want the smallest of these two, which is going to be this dot ship dot angle plus 1 like we just did. And then let's just pick some maximum, and we're going to say minus 50 is the maximum, is the minimum value we're going to go to. So from minus 90, we're going to rotate towards 0, that's going to the right, until minus 50, and it will not get lower than minus 50 or greater than minus 50. So like minus 49, minus 48, minus 30. So that's how we're going to keep the ship rotated kind of like this. And we're going to update our particle emitters frequency. So back up here in frequency, we have it set to 50, right, for both. And so this is how often, so smaller is more often. This is also in milliseconds, how often these particles are gonna appear. So we don't want 50 when we are, we want 50 when we're moving to the right, but we want to change it when we're not turning. So we're gonna make sure when we are moving that we set it back to 50. And then when we're not moving, which is here, right, if right is down, else right is not down, we do this dot left exhaust dot frequency, let's just say 200. So it's going to be 4 times slower. And so that's this for moving to the right, we turn on the left thrust. So for moving left, it's going to be very similar. Okay, right gas to move left. So we are going to do this dot ship dot angle, and just like left was moving, I'm going to copy this, moving, rotating towards the right. We're going to do the opposite and rotate towards the left. And so we're going to subtract 1 instead of adding 1. And then this value is not going to be minus 50. We're going the opposite direction. We're going further away from minus 90. And we're going to say, let's say minus 130. So that's 40 more degrees past minus 90. Just like minus 50 is 40 degrees past minus 90 in the other direction. And same thing here with the frequency. So this is right exhaust. Frequency is 50, and then here when it's off, we're going to also set it to 200. And one more thing, we actually don't want math.min here, we want math.max. Since we're going the opposite direction, we don't want anything less than 130. We want the largest between angle -1 and -130, so you would get to -131, 140. You want to keep it to -130. Okay, so that is going to handle our rotating. So let's actually show you what this looks like now before we add any more code. Okay, we are in this preview here. So you see there's no particles, but they actually are here. They're actually right here, if you can see at the top left, right there. Right there. There's these white things coming from the very top left there. Let's look at our ship actually and see how that works. So I'm going to press the left key, and so now we rotate towards the left. And that's when we're going to turn on our right thrust. Now, if I do the other thing where I hit right, I'm going to rotate towards the right so that we can move that way. Now, we don't have the movement happening yet, but at least our rotating looks to be doing what we want. So now next thing we're going to do is when you hit both keys, right, you basically have both thrusts happening. You're going to go up or, faster in whatever direction you're currently facing. All right, so here's the logic we're going to use for moving. When you're pressing both, they're going to go faster in the direction you're facing. You're pressing one or the other. So let's do this by if cursors.left. So if left or right is down, we're going to want to move you right. So if, let's just give it a speed. Speed is going to be, so if cursors.left and cursors.right. Now, if they're both pressed, our speed is going to be faster. It's going to be 0.03, let's say, and then otherwise 0.01. Now we're going to use Matter.js, Matter physics here, and we're going to use the thrust function on our Matter sprite. So coming up here, we're going to do this.ship.thrust. We're going to give it our speed. Now what thrust does is basically moves the sprite in the direction it's facing. So we already did our angle rotation up here, right? We're doing angle -1, angle +1. Once we come down here, if either left or right key is pressed, we're going to come here. If both keys are pressed, we're going to go faster. If only one key is pressed, we're going to go slower. Then we're going to set that speed to thrust, and we're going to then move in that direction. Now, one thing here, if neither one is pressed, we kind of want to just rotate the ship towards -90 degrees, so it kind of like straightens itself automatically, just kind of like a nicety to have. Let's go else if not cursors.left and not cursors.right. We're going to move our ship back towards center. So, or what we define as center, which is not 0, it's -90. So this.ship.angle, so if it is less than -90, right? So that means we are past -90, so like -130. We are going to do this.ship.angle plus equals, let's just say ½ degree. Each frame that nothing is pressed, we're going to ½ degree automatically nudge you back to center. Now else if this.ship.angle is greater than -90, so that's going to be -50 in like that direction, we are going to do this.ship.angle minus equals ½ degree. So that's just like a nice way so that once the player stops pressing any keys, the ship just kind of reorients itself to idle. All right, let's see what this looks like in our preview. All right, here we go. Let me press left and it's moving. Press right and it's moving. Now look, it rotated itself. Let's see if I can fix that. Okay, if I press both keys, it's gonna go. All right, so sometimes, and this is from experience using Propaganda Lander, I think we did in the end make it so that if you hit the right side of the screen, it would move right, hit the left, it would move left. We did also experimented with basically doing it the opposite way, where if you hit the left key, it would turn on the left thrust, and the right key turn on the right thrust, and then you would kind of move in the opposite direction you were pressing. It does get confusing. Sometimes so does this. Not sure. But here it is, it's working, right? So now the last thing we got to do, add these thrust particles. You see them on the top left here, right here. We are going to put them in the position where they belong on the ship. Okay, we're back here in VS Code. So what we want to do is position our particle emitters to that like 30 degrees off of the center of our ship, and 30 degrees on either side. So minus 30 from the rotation of our ship and plus 30 degrees on the other side. So what we're going to do is get the facing direction of our ship. And we've talked about this a lot in other videos. So what we're going to do here is do const dir. This is going to be a direction vector. I'm going to do new phaser.math.vector2. Let's just say a 0, 0 vector 2. We're going to fill that in. I'm going to do set to polar. I'm going to give it a angle. So let's say this dot ship dot rotation, so which is the angle in radians. So that would be the facing direction of the ship. Now what we want is, let's say 30 degrees to the left of it, let's say. So we're gonna do this, and we're in radians. Now in radians, we can't just add degrees to it. We gotta add it in radians, which math.pi is itself about 180 degrees. So that's like what you can equivalent it to. So what we're going to do is say math.pi times 15% of math.pi, 0 times 0.15, which is going to be roughly 30 degrees, things like 27 or 29 degrees if you do a radians to degrees conversion here. We're going to do that, and then we're going to scale this to 1. So that's the radius. So that is roughly 30 degrees from the rotation of our ship. So let's go this dot left exhaust dot set position. So this is our particle emitter set position, and we're going to do, so this dot ship dot x. So that's the x position of the ship. And we're going to basically translate it in that direction of our direction vector, the negative direction vector, times dot x times 68, which is the like radius, let's say. So our radius was 64, and for our collision box, and 68 is just the right number here. It's kind of a magic number. It'll be different depending on your exact sprite. We just kind of have it that way for this. And then we're going to do this dot ship dot y plus minus direction dot y times 68. Next, let's do the right side. This is the left vector. So using the same direction vector, we're going to give it a new set to polar, and we're going to do this dot ship dot rotation. This time minus, since we added to get to the left side, we're going to subtract to get to the right side for our right exhaust. But same idea here. Minus direction, sorry, math.pi also about 15% of it, giving it close to 30 degrees, and a same length there, radius of 1. And then this dot right exhaust dot set position, this dot ship dot x plus minus direction dot x times 68. And then this dot ship dot y, same thing, plus minus direction dot y times 68. So basically what we're doing here is, given the direction vector of the direction that it should be placed for each exhaust particle, we're going to scale that or multiply that by a length of 68 so that it's in front of that area. So basically where our exhaust is, and then place our exhaust particle there. Each update based on the rotation of the ship. Let's see what we did, and let's see if it actually worked. All right, here it is, the moment of truth. I'm going to press both arrow keys, see if we move up, and we do. Look at that, and those are particles that are in the right place. Now if I rotate, yep, they're in the right place, and it looks believable. like it's a spaceship. So that is pretty cool. So that is here, we have our rotation of the ship, right? You see that if I rotate, and then we do minus 30 degrees on one side and plus 30 degrees on the other side to place these particle emitters in the right place depending on where we move. Now, again, if you did learn something here and you like what we did, give this video a like.